All right, so I've got some practice problems for you. These are all going to be stoichiometry problems. Make sure that you're trying them before you come and watch this video. All right, so we're going to try and walk through some of the problem solving of this as well. Question here is how many grams of sodium metal would react with 10.59 liters of oxygen gas at STP? So, keywords that you want to look for: grams. How many grams? Right, that's what we're looking for. How many grams of what? Sodium, and and now it says sodium metal, right? That doesn't include oxygen, so that's going to be the sodium solid. And how much of that would react with 10.59 liters of oxygen gas at STP? STP is important. What does STP mean? It means standard temperature and pressure, so that's 273.15 Kelvin, 1 atm. That's going to make things a little bit easier for us here. And I think it's also important to note, because we're going to have some mixed problems later, this is 10.59 liters of oxygen gas. Gas, which means that we can use this STP, and that means that we can use 22.41 liters per 1 mole as our conversion factor for gases. Now, considering the fact that we have oxygen gas and we don't have any other information really about sodium, aside from this balanced chemical equation, we should start with 10.59 liters of oxygen, and remember that's a gas. So the general scheme here is going to be, since these are two different elements, two different compounds, we're doing stoichiometry. So ultimately, I need to get to a mole ratio between the two, because that mole ratio will let me convert from the thing that I do know in moles, so moles of O2, into moles of the sodium metal. And then once I know moles, I can use molar mass, and we can get grams of sodium. And then on the other end of our problem here, right, liters to moles, that's the importance of STP here. You could use PV equals nRT, but it's easier to use 22.41 liters as long as you know where you can use it. So starting out with my 10.59 liters now, I want to cancel out that liters and I want to replace it with moles. So that'll give us moles of oxygen, which is the second step here. And then I want to use a mole ratio, which we get from the balanced chemical equation, as 1 mole of O2 to 2 moles of sodium. And now that I've got moles of sodium, I check on the periodic table. Sodium has a molar mass of 22.99 grams per 1 mole. So since I'm looking to find grams, and I want to cancel out moles, put 1 mole of sodium on the bottom. 1 mole of sodium weighs 22.99 grams for sodium. And then we calculate. Oh yeah, that's right. Since I'm recording this way, I can pull up the calculator here. So ignore all those other calculations, but this is going to be 10.59 times 2 times 22.99 divided by 22.41. Enter. So our answer there is 21.728. We've got a whole bunch of decimals there. That's grams of sodium. Now looking at sig figs, this is 4 sig figs, and this conversion factor from 22.41 liters to moles is not exact, which is why I used 22.41 here, and I'll give you that whole 22.41 on tests. So we'll have 4 sig figs, so our final answer will be 21.73 grams of sodium.